Hello. This is convert sorted array to binary search tree attempt. Given an array nums where the elements are sorted in ascending order, convert it to a height balanced binary search tree. Okay. I'll pretend that I know what a binary search tree is. So we have a array nums, and this is our output. So it looks like the output is just a representation of the node structure. So we have the 0 out top, -3 on the left, 9, and then this represents the child of -3, null represents -3, 5 being the left child of 9. Okay, this would also be accepted. So that's, I guess that would look like -10 here, 5, null, and -3. This would be null and 9. And I'm just not saying that's what this is. Okay, but at least I understand what the output is representing, right? -3, yeah, that looks exactly the same. Okay. So we have another example, 1, 3, yeah. Okay, nums is sorted in a strictly increasing order. Gotcha. Okay, so they do give us what the tree node is going to look like. So we have the value, the left and right, and the constructor. Okay. Nums is going to be in increasing order, I believe they said. Yep, in ascending order. Okay, so how do we convert this to a binary tree? I know there's two algorithms for a binary tree. There is depth first search and breadth first search, and I don't really know if we need those here, but now that I'm remembering, I guess we need a way to traverse the tree, right? And that's typically done, or at least I typically have done it with depth first search in a recursive form. So I'll keep that in mind. Let's see. So let's say we have -10 as our first number, right? So that's just going to be inserted because because we don't have a tree node left, or we don't have a tree node yet, right? I know in linked list you'll have like the linked list class and then the nodes. So I'm just curious if it's the same for binary search. It kind of is. No, maybe not. So we'll have -10, and then we'll say we have -3. So how do we say that -3 is less than -10, right? Or sorry, it's greater than -10. So we're going to have that on the right side. I'm going to have the greater than on the left side, or on the right side. And then we'll have 0, which is also greater than -10 and greater than -3. So we'll have 0. Then we'll have 5. 5, yeah, I see where this is going. So that's not going to give us a balanced tree. So I wonder if it makes sense to start in the middle. If we started in the middle and work ourselves outward, we could, in theory, have a balanced tree. Kind of makes sense to me actually. But let's see. So if we had 0, then we have -3, then we have 5, then we have -10, then we have 9. So technically, is this considered balanced? Because the height is still, or it is height balanced, right? And that's all that they were asking for. I guess that would technically work. It's not one of the outputs that they give us. I'm just so unfamiliar on how to insert into a binary search tree. That's why I stuck with the array Leetcodes, but see they threw that one in here. Let me see. So I guess I can actually just try to output this like as an array. Damn, that was a terrible line. So how can we do that? Is there any pattern that I'm noticing here? Not really. Not really. Can't even sort it as an array like that. I'm thinking, okay, let's go back to the middle idea. So that would work if we sort of traverse this way on this side. So -3, and then -10, and then traverse this way on that side, which would be 9 and then 5. And I guess we can do that with 3 pointers. It's just, I feel like that'd be complicated. So we start in the middle, right? If there is no middle, just floor it. And then we'll say, what, iterate while, like while this pointer is greater than this one, and when this pointer is greater than 0. 0, -10. That's a doozy. I guess we could go that way, but I like that pattern or that algorithm doesn't make me feel confident that it'll work with anything else. It doesn't really matter what, or I guess if the length is less than 3, it's a lot simpler. Okay, let me just think for a second about a binary search. Let's just do a depth first search real quick, because I know that's pretty simple. We just have a inner function, I believe. That's essentially going to iterate through the tree node. Oh, we don't have a tree node right now. Sorry, def first search. We're basically just doing like def first search on the left. So like if there was a node, node.left. Node.right. And then console.log value, something along those lines. Yeah, I feel like this is gonna need some knowledge in binary search, and I just don't remember anything about binary search right now. So let's just say we're given a head. I have 5 minutes. I'll just give anything a try. We'll have new tree node, right? And we're gonna say if head.left, then depth first search left, right? If right, depth first search right. Pretty sure that's how it goes. Then we'll run depth first search. Pretty sure that would give us the correct depth first search, and we can just do that by giving it a value. Let's say 5, and then we're gonna give it a new tree node. Oh wait, value, a left and a right. So a new tree node, and then a new tree node, which will be, this is the left, so this will be 4. This will be, let's just say 9 and 3. On the left of 3 will be given 2. And on the right will be given 4. With 9 left, will be given 7. And on the right will be given 10. So I'm just gonna run this, see if I can at least get the console logs. I did not mean node. Thank you. Is it val? Yeah, it's val. Thank you. So I'm just trying to see some console logs here. A function is declared type is neither. Let's return a value. Line 15. It's looking to return. Let's see. And then 19. Yeah, okay. Error, line 19 and 21. Depth first search on head. That is right. That is right. We'll call this node pass node. All right. Cannot find name head. Hello. Return node. Lord have mercy. I just want to see some console logs before my time runs out. All right, so we got 2, 3, 4, 5, 7, 9, 10. That is that right? 2, 3. Wait, 2, 3. Wait, where are these coming from? 2, 3, 4, 5. Oh yeah. Interesting. So I'm printing left first. The left goes down. Yeah, so I'm starting from 2, 3. Yeah, this is cool. Yeah, that's depth first search. Oh, sorry, you guys can see. That is depth first search for sure. How do I insert a node? We're running out of time. Gonna have to do some BST research. Thank you.